Let's see this question. We did a question similar. In that question, we're looking for f of 12. But in this case, we're looking for f of x. So what do? We're not looking for a specific value of f of a specific value. So looking for a function in general. In this case, we would substitute the input square root of x plus 1. So maybe we let k equals to square root of x plus 1. Then we solve for x in terms of k. Because variable is variable, right? If we can write f of k in terms of k, then we can change f of k to be f of x. That's our goal. Okay, solve for x, we get square root of x equals to k minus 1. Then we square both sides. So x equals to k minus 1 squared. Well, k minus 1 squared is just perfect square. K squared minus 2k plus 1. Right? That's our x. So then we use this x value, substitute into this function value of when the function takes a square root of x plus 1 as input. So let's evaluate that. So then x minus 2 square root of x, we want to write in terms of k. So that equals to x equals k squared minus 2k plus 1. Or, let's use square to represent. We don't really need to use this term, because perfect square is a very neat term. So we use this to represent x. So x is k minus 1 squared, right? Then minus 2 square root of x, which is k minus 1 squared. In this case, we get a k minus 1 squared minus 2 times square root cancel each other. 2 times k minus 1. Right? And that's it. So that's f of k, because we use k to substitute square root of x plus 1. So now you see this function is in terms of k, right? So f of k equals k minus 1 squared minus 2 times k minus 1. Right? To be critical, so we need to put absolute value around this, right? Because k minus 1 squared could be 1 minus k squared. Depends on k if it's bigger than 1 or less than 1. Right? If k is bigger than 1, k minus 1 is positive. If k is less than 1, we have to get a 1 minus k in that case. So that's our function. So we can write it as, we can then substitute k back into x. So we get x minus 1 squared minus 2 times absolute value of k minus 1. So that's our function.